Welcome back to another Explainer. Today, we're diving into a genuinely wild chapter of aviation history. We're talking about the Icarus-like rise and fall of the American supersonic transport program. We're going to look at how a technological marvel, something that promised to completely revolutionize the way we travel, was ultimately brought down. And the crazy thing is, it wasn't brought down by a lack of engineering prowess, but by an inescapable law of physics.
So here's the big mystery we're tackling today. Why did a seemingly inevitable technological future, an American passenger jet flying across the globe at nearly 3 times the speed of sound, just totally fail to materialize? I mean, this thing had immense political support, massive funding, and airlines literally lining up to buy it. Yet, this incredible machine never took flight. Let's plunge right into exactly why that happened.
Section 1. The Supersonic Dream and America's Ambition.
Okay, so to really understand the fall, we have to look at the absolute peak of 1960s optimism. Driven by the whole space race mentality, President Kennedy pushed hard for an American jet that would undeniably dwarf the European Concorde. And the sheer scale of the resulting Boeing 2077 was just staggering. While the Concorde was this slender aircraft holding maybe 100 passengers and flying at Mach 2, Boeing's design was an absolute titan. It was engineered to carry between 250 and 300 passengers at a blistering Mach 2.7. It was basically going to be one of the earliest wide-body aircraft designs, completely dwarfing the Concorde in both size and sheer ambition.
And you know what? The market desperately wanted this plane. Airlines worldwide believed supersonic travel was absolutely the future. It was so hyped that many people assumed subsonic jumbo jets, like the 747, would just be a passing fad. By late 1969, you had 26 different airlines from all over the world, including industry giants like Pan Am, Qantas, and Delta, reserving 122 delivery positions. The demand was incredibly real.
Section 2. Physics of the boom, and trying to escape the laws of physics. Because, well, you can engineer new materials and build massive engines all day long, but you can't just legislate away physics.
Now, what's really fascinating here is how these pressure waves actually behave. When aerodynamicists first achieved supersonic flight, they genuinely didn't expect the shock waves from high-flying aircraft to ever reach the Earth's surface, but they totally do. The waves continuously propagate downward, basically creating an immense acoustic impact on whatever or whoever happens to be below.
Actually, we really need to clear up a crucial misconception right now. A sonic boom is not a single, one-time explosion that just happens the exact moment an aircraft breaks the sound barrier. It's actually a continuous air pressure wave that gets dragged along the entire flight path. A single flight from that massive Boeing 2707 would leave a continuous bang zone up to 50 miles wide and literally thousands of miles long. Anyone underneath that flight path is going to experience that boom.
Section 3. Operation Bongo 2, where theory meets the public. To see if a real, actual city could tolerate this continuous noise from overland supersonic transport, the FAA organized a pretty bizarre real-world experiment.
So, they pick Oklahoma City. In February 1964, things actually began pretty optimistically. Some construction workers were even using the predictable booms to signal their lunch breaks. But man, that novelty wore off incredibly fast. By May, citizens were literally seeking restraining orders against the federal government. And by July, the immense public pressure forced the FAA to halt the tests prematurely. The public had completely lost its patience.
To put that into perspective, we have to contrast the elegant, futuristic image of supersonic travel with the jarring reality on the ground. In just the first 14 weeks of these tests, those booms shattered 147 windows in 2 of the city's tallest structures, the First National and Liberty National Bank buildings. Everyday citizens were dealing with cracked plaster, broken glass, and just severe, constant startling effects.
Section 4. The public revolt and the fallout of Operation Bongo 2. What started as this moment of civic pride quickly evaporated into a massive public backlash against the FAA and the entire SST program.
So the crucial point here is the sheer scale, 1,253. That is the staggering number of sonic booms generated by military jets over the city in just 6 months. The FAA was basically exposing 500,000 people to relentless, thunderous noise multiple times a single day.
And here is the direct, undeniable result of that scale, 9,594. That's the overwhelming flood of property damage complaints filed by startled and justifiably frustrated residents. While the FAA later tried to claim that the majority of people could learn to live with the booms, nearly 10,000 formal complaints painted a very different, highly disruptive picture.
But honestly, it wasn't just the physical damage, it was how the government handled it. The FAI flatly rejected 94% of all the damage claims it received. 94%. This incredibly dismissive attitude just fueled massive grassroots anger. It led to class action lawsuits against the US government, and it caused key political allies, who were suddenly flooded with angry letters from their constituents, to completely withdraw their support for the SST.
When the tests were finally abruptly ended on July 30th, the Oklahoma City Times ran this amazing headline, "Silence is deafening." That profound sense of relief underscored a rapidly rising environmental and social movement. These tests directly fueled the creation of groups like the Citizens League Against the Sonic Boom, which very effectively organized all that public fear over noise pollution and potential ozone damage into a truly formidable political force.
Section 5. The end of an era. The Senate vote. Because all of this grassroots anger eventually culminated right in the halls of Congress. In March and May of 1971, the Senate voted to reject further funding, effectively killing the American supersonic dream dead in its tracks.
But the ultimate legacy of this public fear went so much further than just canceling one Boeing contract. The United States ended up enacting a permanent ban on civil supersonic flight over land. This single regulation is what permanently crippled the market for the Concorde and basically all future SSTs. Because think about it, an airliner that can only fly at top speed over the ocean is an airliner with a very limited, heavily restricted market.
Which brings us back to modern aviation. With the Boeing 2707 canceled and the Concorde officially retired back in 2003, we're left with a burning question. Can the sonic boom ever actually be beaten? Because the fight against the physics of the boom definitely did not die in 1971.
And this brilliantly illustrates how the fight continues today. When you look at the overpressure of a standard sharp N-wave boom, that harsh, explosive double crack that was shattering windows back in 1964, and you compare it to modern NASA research, you see a huge difference. They are actively modifying the physical shape of the aircraft to soften that initial shock, engineering a much, much quieter pressure wave. We are quite literally still trying to smooth out the physics of sound to make overland supersonic flight acceptable to the general public.
Which leaves us with this final thought to ponder. We have the advanced materials, we absolutely have the engines, but the Earth's atmosphere itself remains our single greatest hurdle. Will routine commercial supersonic travel ever return, perhaps with those softer, shaped booms? Or are we just forever grounded by the unyielding laws of physics? Thanks so much for joining me for this explainer. Keep asking questions and keep learning.